5.7 extension, I don't know what you want to call it. Here we go. So we remember this completing the square. More often than not, this a will be a coefficient of 1. And when this happens, remember we take our b, and what do we do to our b? We divide by 2 and then we square it. But what we add to the same side, we also need to subtract. All right. So we did that in Algebra 2, and we did that in pre-calc, and now let's utilize it. All right, so let's look at this first example. So we have dx over x squared minus 4x plus 7. And I'm integrating it. Well, what's my difference of power? 2. All right. So it's going to be an arcsine, arctangent, arcsecant, one of those. We just can't do our u substitution, because if I make my denominator u, my du would be what? 2x minus 4. Will that ever be covered here? No. All right. So we have to do something else. Now, which one is it? It's an arc what? It's going to be an arctangent. However, it's not in that form that we want it in yet. We want to get in that form of du over u squared plus a squared, right? So let's get it there. So what we're going to do is we're going to take our entire denominator, and we're going to set it up, and we're going to complete its square. All right. So we have plus blank and then minus blank. Well, what's my b?
4.
No. Negative 4. And I divide it by 2 and I square it. So what did I add? I added 4. So what do I need to subtract? 4. And so now I end up having the quantity of x what? Minus 2, quantity squared, and then plus 3. All right. Again, I never like to not use this little thing right here, because we can just drop that part in right there, remember? So anyway, now I just manipulated it. So now I have dx over the quantity x minus 2 squared. And then how do I want to deal with this 3? I don't really want it working as a 3. I want to think of it as square root 3 squared, exactly. All right. And so now it's in the good form of an arctan. So we can just look at our little note card. What's my a? Square root 3. What's my u? X minus 2. So what's my du? 1 dx. So did my dx get covered?
Yep.
Freaking perfectly. So now let's just look at our note card. So now I'd have 1 over, what's my a? Square root 3. And then arctan of, there it is. And then plus c. All right. So they could ask you to manipulate not just a coefficient of 1 as our a. I don't think that they will. All the AP stuff that I've ever seen always had it as a power of a first x squared. However, they could do this. If you have a 2x squared, what do you have to factor out first? A 2. If you have a 3x minus x squared, what do you have to factor out first? A negative 1. However, I don't think that they will, but they could. I've never seen one, but they could do that to you. You following me? All right, let's keep moving. So let's look at some more examples. I'm not worried about 3. Let's worry about number 12. So on number 12, I have 1 dx over x square root 1 minus the natural log quantity of x squared. And I'm integrating it. So my difference of power is 2. I have a squared and I have nothing up top. So is this going to be an arcsine, arctangent, arcsecant? Which one is this going to be? Some people said arcsecant. Those people that said arcsecant, why did you think it was an arcsecant? Because why? This little x? Yeah, that's not the reason though. Why is this going to be an arcsine? It's a number minus a variable. Okay, it's a number minus a variable. All right. So, what would be my u? First of all, what's my a? My a is 1. My u is what? natural log x. So what's my du?
1 of x.
1 over x dx. Do you see how that portion got covered? Like perfectly. So did that really 1 over x apply for an arcsecant thing? No, because it was a number minus a variable. So now it's ready to go. So now this would basically be like a du over square root 1 minus u squared, right? And so this is just a what? Arcsecant. So let's look at our little note card. We'd have 1 over 1 and then arcsecant of arcsine. Why am I saying that? All right, so this is an arcsine. So then I'd have arcsine of natural log of x plus c. All right. Again, arcsine is a number minus a variable. Arcsecant is what? A variable minus a number. All right. All right, let's look at 49 now. On 49, we have the integral of x dx over x to the 4th plus 2x squared plus 2. All right. So on this one, it's a difference of powers of what? 3. That's weird. Well, back in Algebra 2 and pre-calc, I told you about hidden quadratics. All right, you see how it goes from an x to the 4th to an x squared and then to a constant? All right, and so I want to manipulate this. I want to say this is x squared squared, and then plus 2x squared to the first. And then I'm going to say plus blank, and then I'm going to say minus blank, and then I'm going to plus 2. So I'm going to complete the square on what I like to call the hidden quadratics. All right. So what would be my b? 2. So I'm going to take 2, and then I'm going to divide by 2, and then I'm going to square it. So what did I add? 1. So what do I need to subtract? 1. So now when I manipulate it, what do I have? The quantity of what? X squared plus 1 squared. And then what do my constants go to? Plus 1. All right. And so now in my integral, I'd have x dx over the quantity x squared plus 1 squared plus 1. All right. And so I could say it's 1 squared if we wanted to. So what's my a? 1. What would be my u? X squared plus 1. So what would be my du? 2x dx. Did it cover? Yes, but not perfectly. What needs to come out front? A 1/2. So it's a 1/2. And then what would it end up being? An arctan again. All right. And so we'd have 1/2 of then 1 over 1. And then arctan of what? X squared plus 1 over 1 plus c. All right. Pretty good? All right. Let's keep moving. So let's look at this one now. So now I have a definite integral from 0 to 2 of dx over x squared minus 2x plus 2. Again, what's my difference of powers here? 2. All right. However, what's it going to be? It's going to be an arctan. All right, but we need to put it in that form that we need. So what do we need to do first? Complete the square. Do you think you're going to complete the square on your little quiz and test?
Yes.
It's going to happen. All right. All right, so what's my b?
2.
Negative 2. You did it again. Negative 2 divided by? 2 and square it. So what do we add? 1. What do we subtract? 1. It's not always going to be 1. So then we'd have dx over the quantity of what? What would that go to? X minus 1 squared, and then what? Plus 1. I'm going to call it squared as well. All right. So what's my a? 1. What's my u? What's my du? Did it cover perfectly? Sure did. So what's my antiderivative? You can look at your note card. I encourage you to, honestly. 1 over 1, and then what? Arctan of x minus 1 over 1. And I'm evaluating from 0 to 2. So now I'm ready to substitute in. So I substitute in 2. So what is the arctangent of 1? So when does tangent equal 1? At pi over 4. All right. Remember, arctan goes from negative pi over 2 to pi over 2. Remember that? All right. So then I substitute in 0. So then I get arctan at negative 1. So when does tangent equal negative 1? Negative pi over 4. Exactly. All right. Now, I can't call it 7 pi over 4 because it failed the vertical line test, remember? So we'd have to call that negative pi over 4. So we have we got pi over 4 minus a negative pi over 4, so we add them and we end up with pi over 2. So the area under that curve is pi over 2. So in 5.7, we have concluded the amount of integrals and derivatives that we're going to be doing this year. So you will get this sheet in the 4th quarter, and this is going to be what you're going to memorize. All right. So anyway, you basically have it on your note card, but it will be this form. So in your 4th quarter, this is going to be one of your 2 quizzes. Just straight up, give me the integrals. So I'd have the integral of cosecant u, and you just regurgitate negative natural log cosecant plus cotangent plus c. So anyway, all right, pretty good in the hood. All right, you know all of those, huh? All right, let's look at this first one. We have the integral of dx over x square root x squared minus 1. So, what is it? This is an arcsecant. This is like a legit perfect arcsecant. Now, why is this going to be an arcsecant? It's a variable minus a number. All right, it's a difference of power of 2, and it's a variable minus a number. So this is just straight up arcsecant of, what's my u? Absolute value x. And then it's over, what's my a? 1. And then plus c. All right, I guess I could have a 1 over 1 out there too. All right, let's look at b. So now I have the integral of x dx over square root x squared minus 1. Well, I have a variable minus a number again, right? So it's going to be another arcsecant, true? False. What's my difference of powers? 1. My difference of powers is 1. So what should I try to do first? U substitution. What's going to be my u? What's my innermost composite? X squared minus 1. Just because we have new tools in our toolbox, does that mean we use them all the time? No. All right. So my u is equal to x squared minus 1. So what's my du? 2x dx. Did it cover perfectly? No. What needs to be brought out front? A 1/2. So now I have a 1/2 du over square root u. Well, that u is really to a power of what? Negative 1/2. So what we want to do to that thing? Add 1. So now we have u to the 1/2. So now I have square root u. And then what happens? We multiply by what? 2. So what does that 2 do with the 1/2? They cancel. So I have square root u plus c. But what is u? X squared minus 1 plus c. All right, I don't want you to write out c. I just want you to look at it. So this first one I have, is the integral of dx over square root x squared minus 1. Well, what's my difference of power? 2. So if it's a difference of power of 2, I need to either be an arcsecant arcsine or arctangent. True? That's what we need right now. Well, what do we have? A variable minus a number, right? So it should be a what?
Secant.
It should be an arcsecant, but is it?
No.
No, because I don't have anything covering over here. So we can't do it. Not yet. Not yet. All right. And what I want you to gather from that is we can't integrate everything using what we know now. However, can we derive everything?
Yes.
Yes, but we can't integrate everything. All right, let's look at this next one. We have the integral of dx over x natural log x. All right. So what could your u be? Natural log x. So what's your du? 1 over x dx. Did it cover? Perfectly. So now we have the integral of du over u. Well, what is my antiderivative of du over u? Say it, Hubin. Natural log. So now we have natural log of natural log x plus c. All right, let's look at part B. So now we have the integral of natural log x dx over x. So what could we do now? What's my u?
Natural log x.
Natural log x. What's my du? 1 over x. Did it cover? Perfectly? Yes, perfectly. So now I just have the integral of u du. So what's my antiderivative u du? U squared over 2. So now we'd have natural log of x, quantity squared over 2 plus c. Now, I want to go over a common mistake that I see. I see students do this all the time. What is wrong with that? That's natural log of x squared. Okay? This natural log of x squared, this 2 actually comes out front, right?
Yes.
And so that's basically just saying natural log x plus c. That's not natural log x plus c. You follow me? Parentheses matter. Make sure you put your clothes on correctly. All right, let's look at this next one. Don't write it. I have the integral of natural log x dx. So I make my u natural log x. Then what's my du? 1 over x. Does it cover? No, it does not. So not yet. All right. There we go. All right, cross out 42. All right, on 42, I'm going to go over that tomorrow. Okay? All right.